That's what it was doing yesterday, huh?
Oh. Okay. So I need you to assess your lab procedures to make sure, reading through them, that you have answered the question. The question you're looking, when you're looking for the water in the calorimeter, which is what you start with, you need to be answering Q equals MC delta T. For the water, you're always solving for Q. So you need to make sure you have M, C, and delta T. Make sure in your procedures you have how you're getting the mass of the water, how you're getting the specific heat of water, and how you're going to record the delta, the change in temperature. Then for the metal, what are you solving for? C. Right. You're solving for C, so you're going to get Q from the water. You just need to make sure that you get M and delta T for the metal also. Okay? Go through your procedures and make sure you have all of those parts in there. So you can't just, you need the mass, make sure your procedure says to get the mass. Okay? That kind of thing. Would you get together with your lab groups now and go ahead and do that? Oh! Mass of the metal.
Oh, wait, what?
Yeah, you're not just boiling metal. That's one. Pardon me?
Do we weigh the metal first, or do we weigh them outside the water?
Yeah, I would weigh the metal and then weigh the water, and then you'll know both for the lab. Okay. You probably want to weigh the metal when it's dry. Enough to cover the metal. Yeah, just enough to cover the metal. Just right enough to cover the metal, and you won't know what it is until you see your metal. Right.
Okay. So,
I like the way you spelled that.
thank you.
Okay. You're gonna you don't remove it to cool it, because you have this piece of metal that you need to have it at boiling point, right? So you know the temperature of it.
Mm-hmm.
So you don't cool it down after that, because then it won't be boiling anymore. Okay.
So we're finding the Q. I still see right on. I accidentally wrote this. Like we did a amount of water. I'm a little confused with like your questions for it.
Okay, so this actually looks really good. The only thing that you're really missing, you don't have anywhere where you're taking the mass.
Oh.
You need the mass of the metal and the mass of the water in the calorimeter. Okay. Hey, Chuck, knock it off. I'm ready. It's seriously like avoiding me. Okay. So what do you got?
We confused about how we're supposed to find the mass, the temperature of the metal after we put it in the water.
So you start out with boiling water, right?
Right, yeah, boiling water.
Hey, you put the metal in the boiling water, right? And then it will become the temperature of the boiling water. So you take the temperature of the boiling water.
Yeah. Oh, that's what you're
And
wait, so how do we determine if it's if the energy? We're determining the heat capacity, right?
Yeah.
The heat capacity required to raise the temperature of something by 1 degree Celsius. So when do we?
So you need to know the mass of the metal.
Just the metal.
And then you get it up to that temperature. And then when you put it in the cold water that's in the calorimeter, the temperature of the water will go up. Right? Does that make sense? And then you'll be able to tell the temperature difference from that. So you know it'll go from 100 to the highest point of the calorimeter.
Oh, so the water from 100 degrees, and then the water will, the cold water will heat up to like 70 degrees.
Yeah, or whatever.
So that's the difference.
You're way overestimating how much it'll heat up, but yeah. It heats up a little. Okay. So do you guys know what you're supposed to be doing?
Yeah.
You sound like you're having way too much fun, so I feel like you're not doing the lab.
Great time. We're having a
Okay.
good time, which means
So you guys are missing a few.
yeah, we were gonna ask. So when we boil the water, and then we drop them, or before, like when we drop the metal in, we leave it. How do we check the temperature of the metal?
The temperature of the water. If you put the metal in boiling water, what will its temperature be?
probably boiling. Well, I just want to make sure, and then we drop it in the water, and then we pour the room temperature water after it's in there for...
So you have the room temperature water, so you have a starting temperature for the water.
Yes.
You put the metal in, and then you just record the temperature as it goes up.
Okay, that's what I thought.
Okay. All right.
Okay.
Drew, did you join them? Is that your group?
Yeah. Oh, dang.
Yeah. I'll be hovering and helping you guys. The first trial you'll be like, ah. The second trial you'll be like, oh. Okay. You need to leave in just a second.
Yeah, but do we need to find the mass of the water and the metal in the water?
You need the mass of the metal and the mass of the water. You don't have to have them both together.
Do you need them, like, in the calorimeter?
Mm-hmm.
We need the mass of that water?
You need the mass of the water in the calorimeter and the mass of the metal. You don't need the mass of the boiling water.
Okay.
Okay. All right. Listen up, please. Yes, I get the same job. All right, so we're actually pretty close to ready to start the lab because I know that part of the problem you guys are having is you're trying to visualize what you're going to do in this lab stuff and you don't really see what it looks like, right? So this is what I need you to remember. Would you guys put your hands up like this? There are two parts to this lab. The first part, you're heating the metal up. Okay? When you heat the metal up, you're going to get the starting temperature of the metal. Make sense? I really wish that you could see this. I just want to. Then, the second part of the lab, you have water that's at room temperature, right? When you heat the metal up, you're going to put it into the cold water. The metal will cool down, the water will heat up. Okay? So this is the thing that people get confused on. I need to make sure that you're not doing this, okay? You are starting out with one beaker that has boiling hot water in it. And that's what you put the metal in. You don't need to measure anything but the temperature of that water. That water never goes into your calorimeter. In another beaker, we have water. It's labeled calorimeter water. The special thing about the calorimeter water is that it's labeled calorimeter water. It's just water, okay? It's at room temperature. You pour what you need, just enough to cover your metal, into your calorimeter, and you take its temperature, okay? The only part of the boiling water that's going to go into the calorimeter is the metal itself, okay? So you need the mass of the calorimeter water and the mass of the metal. You need the temperature of the boiling water and the temperature of the cold water. You need the starting temperature and the ending temperature of the cold water. Do those things make sense to you? Now, visualizing how you're going to do the lab, you're going to go through the first time and your hair is going to be on fire and you're going to be like, I don't know what I'm doing. And then they'll be like, oh, wow, really? We just cooked metal and put it in cold water. All right? Then you'll do the second part of the lab and you'll be fine. Does that make sense? Yeah. Okay, because it's just the first time you're trying something. So what I need you to do now is make your data table. And in your data table, please make sure you answer Q equals MC delta T for the water and the metal, for your known, which is aluminum, and your unknown, which is not aluminum. The only thing I will promise you about your unknown is it is not aluminum and not radioactive, I think. Okay? Make your data tables. Look at your first one. Just a second. Find the temperature of the boiling water. So in your data table, what are you going to be recording?
Temperature.
Okay. The second one. Put enough water in the calorimeter to cover the metal. Okay. And then find the mass. So what are you going to record?
Mass of both.
The mass of the water, right?
Oh, just of water. Okay.
Okay. Then before you place the metal into the water, make sure you have the mass of the metal. Do you have in your procedures anywhere to put the mass of metal?
map. I just
Okay, so everything that you're measuring should show up in your data table as
Okay.
or something you're recording. Does
Okay.
that make sense to you?
Yeah.
Okay. So it doesn't. There's not a particular order I need you to do it in, but obviously you're not going to want to like boil the metal and then weigh it.
Okay.
So you might want to start with that. So just make sure your data table shows everything that you need to record.
Okay.
Okay.
Starting metal temperature. Starting. Okay. I just want to know like what to record. So.
Right. So look through your procedures. What do you?
Yeah, but
So you said to heat the water with metal inside. Okay.
Yeah.
But did you say to weigh the metal yet?
no.
So you need in your procedure you have to weigh the metal. Then in your data table you would write the weight.
Okay, so I just want to know. So you record the weight of the metal starting, and then the starting temperature when it's boiled,
Right.
and then you record the mass of the water.
Only the water you put in the calorimeter, not the boiling water.
Okay.
Okay.
And that's all.
And you
of
need the
them?
mass of the metal.
So.
Okay. And then when you put the metal into the water, what do you need to know about what happens to the water after that?
This mass afterwards.
The temp afterward.
Temp.
The mass isn't going to change. It's the temp afterward.
So temp water.
Yeah, because you remember you need T final and T initial. T initial is boiling. T final is when they even out.
So cold water, hot water, final water, and the metal.
Right.
Yeah.
You got it.
Yeah. That's my question.
The boiling water will give you the starting temperature of the metal. Then when the water heats up as much as it can, that's the ending temperature of the metal. So remember, we're doing everything by looking at what the water does. That tells us what the metal does. Just like in titrations, what the base did told us what the acid was.
We will only have one column for metal heat, like, right?
It's the temperature of the boiling water.
And yeah.
Okay. So you'll have one column for the temperature of the water. You're never going to actually take the temperature of the metal because our thermometers don't work that well. Okay. All right. All right. Yeah. You have hot water. You have the metal. Is that mass or what?
The
Okay.
M is mass.
Okay. Yes, that looks good. All right.
That's really weird.
No, actually, yours looks a lot like everybody else's. So, unless they're all weird.
Mine's weirder.
All right.
The I and the F is in the show.
That totally makes sense. This is actually absolutely perfect. You're not going to need a final temperature of the boiling water. You only need a final temperature of the cold water. Okay. All right. So are you working with them?
Yeah.
Okay. So you guys, you have a good data table. Now make sure your whole group has it. Okay. All right. All right. So what do you guys got? Ready?
Initial temp, initial mass, final temp, final mass for water. Not mass, temperature for metal and water.
Okay. And you have it for your unknown metal and your known metal. You're only doing one trial of each. You don't need three.
Oh, okay.
Okay. We don't have time to boil the metal three
So only
times.
2 trials?
Yep. No, hold up for just a second. I need to talk about lab safety.
Is the procedure?
It looks decent. As you're going through and doing the lab, if there's something that you realize you changed, just change your procedure.
And then, do I measure temperature of cold water, temperature of hot water, mass of the metal,
Uh-huh.
mass of the water,
Uh-huh.
metal weight, and then
That was the mass of the metal is the weight. Okay. But yeah, that looks good. Okay. Now I need you guys to listen up. Joe, turn this way, please. All right, everybody. I looked at your data tables and I looked at your procedures. And I do see that some of you are missing some parts. But as you're doing the lab, you'll figure out, oh, I should have written that down. You can write it down. All right, so you can just fix your procedures as you go along. You're doing this for the first time. As you're doing this, I want you to be thinking, because you're going through and you're putting together this stuff yourself. I want you to think, when you get done with the first one, and you've solved Q equals MC delta T, and you've figured out for aluminum, when you're done with that, look back through what you did and think about how it worked, and figure out if there's something that you can do better. Figure out if there's something that you can do better for your other metal. Does that make sense? Okay, so the first time you do it, you know what the answer should be, so you're just figuring out how good your materials are. The second time you do it, I'm expecting an answer from you. Now, for lab safety, I don't care how yummy that water looks when you're boiling stuff in it, you may not drink it. Boiling water is hot. It is what we use to cook things. Please do not cook yourself. You must wear goggles and bubble wrap. Okay. Now here's the thing, though. One of the issues with this lab is that you're taking a piece of metal and you're putting it into boiling water. Okay? So you're going to take your tongs, and you have your metals, by the way, they look more like this, your unknowns. All right? So you're going to take this metal that you've already weighed and everything, and you're going to put it very carefully into your boiling water. Because if you don't put it very carefully into your boiling water, you could break my beaker. And that would be tragic. And also you could be hit with boiling water, but I'm worried about my beaker. Okay? So I need you to be really, really careful with that. So some of you are really happy, which I get, it's Friday. But when we're doing this lab, I need you to be quiet. I need you to be working carefully, and I need you to make sure you're like working with your group to make sure the lab works well. Okay? Because you don't really know what you're doing yet. You're figuring it out as you go, right? So as you're going through and doing this, make sure that each person is paying attention to what you're supposed to be doing. In this step, make sure that you weigh the metal before you put it in the water, that kind of thing. Because if you weigh the metal after, or if you put it in the water and then realize you needed to weigh it, you're going to have to like make sure it's perfectly dry to weigh it. Okay? Do you have any questions about what you're supposed to do? All right. I feel like you guys are ready to go over and get started. The very first thing you're doing is weighing stuff. So that, I'm figuring you can do on your own. Yes? Don't knock over the camera, you guys. Pictures. Did you not get my message this morning?
It'll be similar. Well, they're not going to change it.
Okay, get them both weighed and get them in the water right away. Oh, you're... Goggles on, gentlemen.
What?
Settle down. Can we start? Yeah, soon. So start by weighing your metals, right?
Eric's taking too long.
They get cleaned every time. That's why we put them in. So weigh it. Come on. That's your aluminum, yep. Okay. Goggles on, and make sure you start by weighing, right?
I forget.
Where's your other metals? Okay, so weigh your aluminum. Yep. So that's your unknown. So record the mass. Did you record the mass?
Not yet.
Okay. You weighed it and recorded the mass? Okay.
How long do we
Take what? Oh, is my badge interfering?
So, how long do we...
Just a couple minutes while you're getting your calorimeter ready.
Okay.
Okay, you guys see this size? Hey, you guys look up here. You've seen the size of your aluminum now. It's the silver stuff with the hole in it. You only need to put enough water in your calorimeter to cover your aluminum. While you're boiling your aluminum, you can get your calorimeter ready and take its starting temperature. Okay? So, and then when you're done boiling it, the aluminum will be ready. You can put your unknown in the water at the same time as your known. Just make sure you have the mass of both.
So I think we goofed. Pretty sure we take the initial temp of this water and then after
You have both of them. So you have the initial temp of that,
Okay.
and then while you've got that boiling, you put calorimeter water in, just enough to cover your aluminum, so maybe up to here.
Okay.
And then you need the mass and the temp of this.
Okay. The initial and final too for that, right?
Yep.
Okay.
All right, so you got your metal, you weight it. Okay. Just
Go ahead.
all right, so you weigh it, and then you put it in your boiling water, and then you get your calorimeter with just enough water to, like, you can put the aluminum in it, and then take the temperature of the starting calorimeter temp, and then your aluminum will be warm enough. Okay. With the thermometer, aren't there two thermometers sitting here?
Yeah.
It's gonna go tall.
Okay. Get off your phone.
Wait for the metal.
There you go.
Right there. Don't get wet.
Only one at a time, because you're unknown, you'll have to put in new water. Okay. If you've taken the temperature of the water in your calorimeter, that's too much water in your calorimeter.
That's too much, Logan.
Because you're going to be able to put the aluminum in sideways, and if you don't have too much water in it, then it changes the temperature better. Okay? Yeah, that should be good. So then you need the temperature of that, right?
Yeah, Logan, take it.
Okay. And you need the mass of the water, right? In your calorimeter. What's the matter?
I don't know when to take it out.
To take it out. When you have the mass of your water in your calorimeter and the temperature of the water in your calorimeter, then that's been in long enough that you can switch them over.
25.
But remember, you need to have a lid on it when you put the metal in, so you put the lid in.
Celsius?
Can I do
Yeah.
that?
Yeah. Okay.
So that's
All right. So now what do you got?
We're figuring the temperature of the
Temperature what?
the water.
Okay. So and then when that's done, you'll carefully take the aluminum out and put it in, right? You'll make sure you have a lid that fits, and make sure that you know how to get the thermometer through the hole in the lid. All right. So while you guys are you're getting your water ready, right? You need to make sure you have a lid that fits and that you know how to put the thermometer through. Okay.
Where's our?
Don't break my thermometer on the metal. You want to have it double. So what did you guys do? Double it up so that your hands aren't there. So you want it double. Okay.
I guess.
Yeah, that's your starting temperature.
Okay.
So you got the temperature of the water? You wrote that down too? Okay. So when you have the starting temp of this, make sure you have a lid that fits your calorimeter and you know how to put the thermometer through it. And then you're going to carefully take the aluminum, put it in, put the lid on, and you're waiting the temperature as high as it goes.
Okay.
That's what you're doing. Okay. So you guys are waiting for water to boil. I'm sorry, the fuse blew out on this one, so it was on. All right, so just like life advice, don't leave these sitting on heat. Okay. All right, so you guys have your calorimeters. You only put in enough water to cover your metal, right? That looks a little bit more than you need. Okay. So, but the problem with it is if you have a lot of water, the temperature doesn't change much, and so you'll be less accurate. Okay. So you just want enough to cover this, right? You have the mass of this, and then you'll need a new mass of the water.
Oh, I have the water.
Okay, this is the aluminum. You do the aluminum first.
Oh, right.
Okay. So then on this, you want to make sure your lid fits,
And then you poke it.
and the thermometer goes through it, right? Okay. You guys ready? Let's see what you got.
It's not.
You leave it in, take the temp. So what was your starting temp?
24.
24, and now it's like 28. It's not going to go up a ton. It's just, you record the highest that it goes.
Okay.
Okay.
How do I find the final?
I know you were hoping for like 90, weren't you?
Yeah. What about final temp of metal?
It's going to be the same as the final temp of the water because the metal's what made the water go to that temperature. Yeah, you guys, what you guys did was exactly what you're supposed to do. As long as you have the mass of everything, you're good.
Yeah.
Now, when you go to do your unknown, you need new water, so you need a new mass and a new temperature.
Okay.
All right. How'd it go?
We'll see.
You have a starting temp? Okay, so when you're doing your unknowns, Danny, you're going to need new calorimeter water and then the temperature again.
Okay.
Okay. But you guys are doing it exactly right. It's not going to go up very much. All right, so let's see. All right, you put the lid on it. What was your ending temp?
37 cells.
30 cells? Okay, great. Now you're going to need brand new water.
Yeah.
And then a new mass. You broke my thermometer?
Yeah, I'm sorry.
It was my favorite child. Okay. I have a whole collection, just like children. Here you go. Okay, so when you guys are doing your unknown, you guys have the masses of these, right? Brand new water for the calorimeter, new temperature, new mass. Okay. All right, you guys. You are having so much fun here. It's ready. You can put them in now, and then it'll start boiling with the stuff in it. Okay. Okay, don't put it down all the way to the bottom. Look at that water. Doesn't that look yummy?
Good thing it's double cups.
What do you mean? Until it stops going up. You're looking for the highest temperature it gets. Okay.
We do, because when you take, once you put it in, it's going to change that temperature, so we have to dump it out to get it.
All right, so make sure you dump all the water out of that cup. Like, don't put it full of boiling water in here. Make sure you dump the water out of the metal.
Of the thing.
Yeah, okay, makes sense?
Do we just keep it in there until it starts like boiling?
You're good.
Again?
Alright, I'm good to go.
Okay.
That's probably good right
Why
there.
does it look like
Is
that's
this your
smaller?
first thing that you're doing?
Yeah.
Put this one in 2. Do you have the mass of this?
Yeah.
Okay. You want it in 2 so that
bro, you
it's
got-
ready when you are, because it'll be
I
quick
know.
after this. You got it all done? Oh, you guys, yeah, just a sec. Drink it. No, yeah. Dump down the sink. You'll need brand new calorimeter water for the next truck. Okay. Yes.
Both at the same time.
Say that again?
Are you able to put both?
Yeah, you can put both of them in at the same time, and they should be ready to go to switch over really quick here. Okay.
Cool.
Alright, so you have the mass of both of them, right?
Yeah.
Okay, then you're good.
Measure the mass.
Do you have it on your
Not
data
that
table?
one. Yeah, we did. Oh yeah, I did.
Okay. If you have the mass written on your data table, if you all have the same information, then you will know what's happening. So, would you get the masses on your?
Both of them.
You got them both? What was your temperature change for both of them?
This one went up 4 and this one went up 6.
Okay, so you can tell just right there they don't have the same specific heat. Put your goggles back on until you're not by the boiling stuff. Okay. All right, so that's a sign to me that you did it right.
Okay,
Does that make
cool.
sense? So now what I need you to do to turn your heat off. Actually, would you unplug these things?
Yeah.
And then head back over to the other side, and you're solving Q equals MC delta T for the water, solve for Q, and then for the metal, solve for C, right? So you're just going to answer the problems.
Okay.
Okay? No, just turn it off and leave it. You're great. We have to. You're right. How's that? What just happened?
It's like 33 right now. Check the look.
Okay, so that's probably been boiling long enough, but you don't have water in your calorimeter yet, so you can't do the lab yet.
Oh, this kid.
I know.
That was not my job.
Set it down to 4, please.
You're calorimeter guy.
Yeah, Logan's talking about it.
You guys getting close?
We are done.
See, how bad was that?
I mean, I stabbed the hole through a cup. We broke a couple things, but
You guys are a hazard, but you got it done right. So, what was your ending temp on this?
29,
So from 20 to 29ish? 25 to 29? Okay.
Yeah, we went-
Oh, you had a ton of water, that's why. So your temperatures are different, like the amount that they go up is different because you had different amounts of water in there. Okay. And different metals actually for you guys. So when you're done, would you unplug this and then don't try to dispose of it because it's going to be screwed up. Yeah, so organize your tables and then go to the other side.
That one is a little H2O. This one.
Yes.
One taller than the other.
Yeah.
seems about.
Okay.
Oh. Here, move it over here, dog. Move it over here, dog.
Ours was very rusty.
Okay, put it back in the water.
Yeah, what do we do with this? Do we leave it?
Leave it in there for 1 minute. Yeah, just leave it. 1 minute. And then when you've got, then put it back in quickly. Okay. All right. How's it going?
My forehead is fatty. You always get the really tight stuff.
All right, so you're just waiting for the water to heat up?
It's
So
like a
you're
particle
30.
in there.
It's what?
Like a metal particle in there.
Oh.
Source of error.
Well, it's interesting anyway. So are you guys all done with this?
Yeah.
Would you unplug it for me, please? I don't trust these fuses to actually turn off if it catches on fire.
Don't worry.
Okay.
Well, we didn't weigh our
Go
water.
ahead, now you can pick it up.
We didn't weigh our water the second time, so.
So now you're doing it again?
Yep.
No. What are you doing there?
I don't know what I'm doing.
Well, that was clear, but you got it. So if you need to put that back in the boiling water.
Yeah.
Okay.
This one. This one. This one.
Perfect. Okay, lid on fast. You don't want to lose any heat. Thermometer in. There you go.
Move the tongs. I don't want to get burned.
It's really not hot anymore. It's in the cold water. Got it?
Yeah.
Okay, Mariah, Cameron. Q equals MC delta T. Solve for the water, okay?
Whoa, which one was that one? So is this one.
Okay, got it? You guys are catching up to everybody. You got to do it fast. Okay, but you're catching up to everybody really well. How did it go?
Just letting it go still.
Okay, it's not going to move very much because you had such a little unknown.
Okay.
Okay.
Yeah, 2.13 is just the same.
Okay.
Does heat transfer go by surface area or mass?
Both. Because if you have more of the surface exposed, the transfer will happen faster, right?
Alright, we're at 31.
How long are you supposed to leave it in here until you take it?
Until the temperature stops going up.
Okay.
Another one? That's 2.
Mercury?
These are alcohol thermometers. Can I play with the mercury? Are you done?
Yeah.
Okay, so you broke my thermometer as your parting shot. Okay.
I don't think
You guys all done?
Yes.
Would you? Oh, I'll do it. I'm sorry, say that again? Would you unplug it, please, if you're all done with it? Thank you.
All right, I'm going to head back over to the other side. All right, you guys see follow-up questions? The calorimeter water.
Okay, so now we have that.
You guys see the follow-up questions? Yep.
So what we're using in this equation is like the mass, right? So do we add the metal and the water together?
Just,
or just the water?
When you're solving for the water, use the water's mass. When you solve for the metal, use the metal's mass. Like in the notes yesterday.
Okay,
This is the correct.
That's your mass of water?
Yeah.
That's C of water?
Yeah.
And that's start minus, so that's 5? Yeah, that looks great. Okay, so now that's Q, so you know the Q for the water. So what is it for the metal?
No, we use the mass of the metal.
Yeah, you use a mass of the metal, but what is Q for the metal?
What?
Yes, he did.
Yeah.
So if this is the Q of the metal, then, or of the water, what's the Q of the metal?
Q of the metal. Wait.
Remember this? Q
Right.
equals negative Q, right?
Right.
So what are you going to do with that?
It's about equal to the next equation.
Yeah, but it's negative. Yeah, you got it. What'd you get?
We're trying to, we're trying to get specific heat, right?
You're starting, no, for the first question, solve Q for the water. So you're looking for Q. You know the specific heat of water.
Yeah, okay.
Okay. So remember when you're doing the water, you just use the water values of the water in your calorimeter. Okay? How's it going, gentlemen?
Pretty good.
I think I did it right.
Let me see what you got.
My answers, the top one, current answers are a little bit different.
So this is your mass of water?
Mass of water?
Yeah, you're solving for water, right? So you probably should have the mass of the water in it.
Oh, okay.
How much water did you have in the calorimeter? What was the mass of the water?
120.9.
That's what you would put here.
Oh, okay.
And then when you do that, this is the temperature of the water in the calorimeter.
Yep.
That will give you Q. Just make sure you're using the mass of the water.
Okay.
So when you switch to solving for the metal, use the mass of the metal.
Oh.
Does that make sense?
Yeah.
Okay. How's it going? I know you haven't been here for like a year.
Yeah.
Okay. Let me see what you
So
got.
I don't have the data table because I did the experiment, but
Because what?
I did all the experiments so they have the numbers.
Okay, so how about you flip over there and start writing it down. Okay. It's just joules. Yeah.
So you just write J next to it then?
Yep. What'd you get? Oh, you don't know yet?
No.
Okay, wait, I'm really confused on like the equation. Like I wasn't here yesterday, so I don't know.
Yeah,
Do you want to take a picture of my notes?
I love AP Week.
I think I have a picture.
Okay.
So M is the mass of the water in the calorimeter.
Okay.
Okay.
C is the specific heat of water, which I know you don't have the notes.
I copied them down.
Okay, it's 4.18 right here. Okay.
Okay.
And then delta T is you had the starting temp of your water and your calorimeter and your ending temp, right?
Yeah.
So your delta T is the difference between the two. So how much did it go up?
So you said M was the mass in the calorimeter, right?
Mass of the water in the calorimeter, right? Yes.
Wouldn't like 509 joules be about like?
What's your mass of water?
Isn't it the starting? Oh wait,
No, the
temperature?
mass.
121.
That was the mass of water in the calorimeter? That's the right specific heat. So you're saying you put that piece of aluminum in the metal or into the water, and the temperature of the water went up 1 degree.
Yeah.
Okay, and that's right.
Okay.
It's a little low,
Yeah.
so just keep that in mind when you're doing sources of error. Okay.
So
now that you have Q for the water, what is that for the metal then?
Well, I know we take the negative Q.
Right. So then you take, when you have negative Q for the metal, you're solving for the specific heat of the metal.
Oh yeah. Okay.
And remember, you know the value for aluminum, so you're just trying to figure out how good it was.
Yeah.
Okay. How's it going?
Good. Do you take the 4.1?
Yep. And that's the right delta T, and this is the mass of the water in your calorimeter. Okay.
Would we use 4.1 blah 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 for everything?
No, the 4.18 is only for water.
Okay.
So then when you're doing the second one, so when you're doing question 1, you get your answer is Q, right? And then you know that Q of water is the opposite of Q of the metal, so then you'll have the Q of the metal. And then you'll solve for C of the metal, which is 4.18 for water, not 4.18 for the metal. Okay?
Yes.
So solve for Q first, and then I'll come back and help you. Okay. All right, I'm here to see how you did.
Is that so? Does it look right?
All right, let me see your work. That's your mass of water?
Yeah.
That's your specific water. Okay. Yeah, I was thinking it should be a little closer to like 100 grams. Remember, when you're solving for water, use the values for water. Okay?
I want to make sure we got
H2O.
We have 2,416.71 J.
So that was your water, and yours went up 6 degrees?
Yep. Yeah.
Okay, that's it.
Okay, cool.
All right, and then what's the second part? Now you're making sure that you're finding what your specific heat is of the aluminum. You know it's aluminum, so what should it be?
How did
Yeah, it's yesterday's note. So you know what it should be, so you can compare it to what you actually got. Let's see what you got.
I just started.
that one?
Okay.
I need to write
Let
that
me
down.
see.
Aluminum.
Q equals MC delta T.
For 2,
I got it. Alright,
so
you plug in what you got from the first one into Q and then solve for C.
You just make sure that you remember Q equals negative Q, right?
I should have.
So the Q of your water is negative Q for the metal. What was your starting temp for the metal?
24.
Your starting temp for the metal was 100.
Oh yeah.
Okay, so make sure you have the right delta T. Okay. Yes, Danny.
Have we read the second equation?
Yeah, the second equation.
Okay, you have Q equals MC delta T, and what are you solving for?
C.
Okay, so you're just going to move the equation around till you're solving for C.
Is this still 27 minus 22?
No, but what was your starting temperature of your metal?
Oh, it's the metal.
It was the boiling water, right? So your delta T will be different.
That's right.
So would it be like Q over?
Wait. Your metal started out at like the boiling point of water, so your T initial is like 100 degrees.
Right.
Okay. All right. And then your T final is the temperature that the water went up to, is the temperature the metal came down to.
So it's 27.
Right. So that's how you end up with a negative number, so your negative Q cancels out.
So for the example, we had 25 minus 100. So would we use like the number from the hot and the ending temperature from the calorimeter? Okay.
Yep. So because the metal cooled down as much as the water heated up, they ended up at the same temperature.
Okay.
Okay. All right. What do you got?
So I got Q equals 1,279 calories.
Okay. So do you guys have the answer for this one?
No. I'm explaining it. Yeah.
Okay. Thank you. Yes, that's it. So then, that's for the water. So remember the water and the metal end up like at the same thing, right? So the Q for the water is the opposite of the Q for the metal. So when you're doing question 2, you'll use negative Q.
Negative Q.
So you have Q for this, and then you'll use negative Q to start.
And then with this.
Okay. And then you plug that into point C.
Right.
So what's delta?
Change in temperature. So for the metal, it started out at the boiling point of water and cooled down to as much as your water heated up.
C is
Okay. Remember yesterday when we did the practice, that was the negative temperature because it cooled down. All right. I need your attention now, please. If you would stop what you're doing, put your pencils down and look up here. All right. So, how many of you found Q for the water? All right. How many of you are pretty certain that the Q that you found was actually for the water? You used the mass of the water, not the mass of the metal, to find Q. Okay. If you didn't, go back and fix that. Okay. On Monday, we're going to have to finish. There are 7 follow-up questions, and we're going to need to finish those on Monday. All right. If you got to the point where you found Q for the water, then you know that you're going to make it negative Q for the metal. So you're solving for C. If you have time, I'd really appreciate it if you come in on Monday with an answer to the question, what is the C of this metal? It should be about 0.9 because it's aluminum. We know that's about 0.9. I'm looking for how close you are to what reality should have been because we're using different materials and you tried it once. Okay? You got 0.81? Actually, that's a really good number. For the first time you tried to do it it's a good number. Okay, go ahead and pack up.